Today, I'm going to talk to you about three different ideas. Number one is Newton's first law, which essentially states that an object will remain at rest or in uniform motion in a straight line as long as there is not acceleration or another unbalanced force acting on it. In other words, if the net force is zero, the acceleration will also be zero. Within this law, it also illustrates the resistance and change in the motion, also known as inertia. See, right now my inertia wants me to keep going straight. And the car is traveling in a straight line and at constant speed, so the net force is balanced. But if the car were to brake really hard or turn, then my face would smash against the dashboard or against the window, and this is why you should always wear a seatbelt, because then there would be acceleration and thus the forces would be unbalanced.
But let's say the net force and acceleration weren't zero. What then? Well, this is where Newton's second law comes in. It states that the acceleration of an object depends on not only the force acting on it, but the mass as well. This can be represented through this formula. This is valid for all objects with unbalanced forces, as it shows that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to the mass of the object. Before I knew all of this, I was kind of confused because when I went grocery shopping and used the same force needed to push a full shopping cart to push an empty one, the empty shopping cart always went faster. This can be explained by these two FBDs. You see, both have the same applied force. However, due to the fact that the empty shopping cart, which is represented by FBD A, weighs less than the full shopping cart, which is represented by FDB B, the empty one has a greater acceleration, which you can also see by the calculations on the side. However, if you're still not getting it, then this picture perfectly illuminates the difference. You see, the larger the mass, the lower the acceleration, and it's as simple as that. Finally is Newton's third and final law, which is also the reason I win every single fight without even throwing a punch. It states that for every action/force, there is a reaction force that is equal in magnitude and opposite in direction. So take me and my brother fighting, for example. If he smacks me in the face, technically he smacks himself as well. This can be explained in these FBDs. A represents Mustafa's hand, and B represents my face. You see, the force of A on B, his hand on my face, is equal to the force of B on A, my face on his hand, which means that technically it hurt him just as much as me. Sure, he hit my face and there's a lot more nerves and it's really sensitive, but technically I hit him without even throwing a punch. So